Right then, so in this video we're going to be answering our 5th exam style question looking at A-level maths differentiation, and more specifically looking at differentiation from the product rule. And in this question we need to differentiate e to the 3x cos x, and it goes by saying that the first step we need to take is actually figure out what style of differentiation are we going to use. And there's two very important facts we can actually deduce from this expression. And the first fact being that we have two functions, and those are e to the 3x, so that's our first function, and also we have cos x, which is actually a separate function. So I'm just going to write we've got two functions. And then the second important fact is that those two functions are actually multiplied by each other. And we can't actually see that in the expression, but because there's you don't actually write it times, you wouldn't write it in between e to the 3x and cos x, but we know that those are actually multiplied by each other. So I'm just going to write that down. So we've got the functions are multiplied by each other. So the two important facts being that we've got two functions and that they are multiplied by each other. And these two facts actually mean that we can use the product rule. So I'm just going to write that down here. So that means we can actually use the product rule. And what I've actually done is written the product rule on the right hand side here. So that would be this here. Right, so we've got dy by dx is equal to f prime x gx plus fx g prime x. And you can even see here that we've got two functions which are fx and gx, and by that same notation I'm going to assign e to the 3x as fx, and I'll call cos x as gx, and I'm just going to make that clear to the examiner. So I'm just going to say let fx, and we're going to call that e to the 3x, and let's say we'll call gx by the notation, we're going to call that cos x. And now if we look back to the formula, you can see that we're actually going to have to differentiate both fx and gx. Now we could just do that whilst we're actually using the formula, or we could do it right at the start, and I'm just going to actually do it at the start, so once we do use the formula it will be much easier to use it. And that's exactly what I'm going to do. So let's say, therefore, let's do fx first. So f prime x would be now e to the 3x. Now the way we actually differentiate this is first we take the power here, and we've got 3x, and we're going to differentiate that, and we're just going to get the number 3. And actually what we're going to do is take that to the front here, and once we do that we get 3, and the rest of the expression stays exactly the same. So we have therefore 3e to the 3x. And now let's do gx. So we'll have therefore g prime x. Now this is very important. Now as you can see here we've got a cos x, and this is something that we just learned, that cos x, once we differentiate this, will be minus sin x. And once we've done that, we have both the f prime x and g prime x, so which is 3e to the 3x and minus sin x. And now that we've done that, we are actually ready to use the expression for the product rule shown in the red box above. And so first of all I'm just going to say just to keep it consistent, I'm just going to set my expression here in terms of y. So I'm just going to say y equals e to the 3x cos x. And now we've got in terms of y and x, and now we can easily differentiate this. So we've got, therefore, dy by dx. Now I'm just going to take it piece by piece so we don't actually get the expressions mixed up. Alright, so first bit, we've got f prime x, and we can see from this part here that that would be this expression here. So that would be 3e to the 3x. So I'm just going to write that here. 3e to the 3x. I'm going to times it by gx, which is our second part. You can see up here. And gx, if we come down here, we will find is actually cos x. And once we've identified that, we're just going to write cos x. I'm just going to put these both in brackets so we don't get mixed up with the second part. Right, so then we're going to add it to the second part. First of all, we have fx, and if we come back here, we can see that this would be e to the 3x. So I'm just going to write e to the 3x, and finally we've got g prime x, and we also worked that out here. We said that was minus sine x. So that's minus sine x. And just to actually initially tidy this up, we could say, instead of just putting the times, we could just leave that out. So we've got 3e to the 3x cos x. And what we could do here is, like you could see, we've got a minus sign, but we could just take that in front. So plus times a minus would be a minus. E to the 3x sine x. And that is a much better way of just writing it initially, where you've just got a minus in the middle of the expression. And what we could do is actually take this a step further and realise that in both of these parts we've got actually e to the 3x, and we know that because we've got two expressions and part of it which is actually both the same, we could actually factorise that outside, which would be e to the 3x, and that's actually what I'm going to do. Therefore you've got dy by dx. Alright, let's do that. So we take e to the 3x outside, and the rest will stay the same. So we've got 3 cos x, and that next part would be minus sine x. And you could see that if you times this out, you'd see that you would get 3x cos x, and then you get minus e to the 3x sine x. But that's how you can actually solve and differentiate this expression, and that will actually give us 3 marks. And like I was actually saying, you could leave the answer here, which would be perfectly valid, and you'd get the 3 marks. But I think it's a much better way of actually factorising it, and if that is a possibility, then that is actually something that I would actually definitely consider to do. And you could see here that in this case we could take e to the 3x outside of the expression. Right, so that's how you can actually differentiate using the product rule, and I hope that was helpful.